Hey all, Dawson here, back with some more awesome math videos. You know how I am. I just have the best math videos in the world. So anyways, today we're talking about graphing inequalities. And my essential question for today, I think is quite appropriate, which is basically asking, how on earth do you graph a line with a greater than or less than sign? Because most of the time when I work with students on graphing inequalities, they will ask that exact question, like, what are you talking about? How does this work? Well, let me show you how it works, and it's not that bad, I promise. So you get the equation. It looks something like this. Y is less than or equal to 2/3 x plus 1. And you say, whoa, hang on a second, that's a weird symbol. I don't know what the heck I'm supposed to be doing with this. But don't stress out. Don't worry about it. Just relax. And for now, we can just pretend it's an equal sign. So just kind of ignore that and just say, well, it's close enough to an equal sign. At least it's in the right place. So let's just call it an equal sign. So just pretend. We're going to do the exact same thing we always do when there's an equal sign there, which is to figure out, well, what's my y-intercept and what's my slope? So on this one, the y-intercept, if I could do some equal signs here, the y-intercept is the same thing. It's still plus 1. So there's my plus 1 for my y-intercept. And my slope is still the coefficient of x. So in this case, it's 2/3. Well, that's not bad. That's about the same as what we've done before, right? No big deal. In fact, we even go over here to the graph and we do the same thing we've always done. I take my y-intercept and I plot that point. There's my y-intercept at plus 1. And I use my rise and my run for my slope, 2/3. 1, 2, my rise, my run of 3. Plot my other point, and I can keep doing that and get a continual string, rise of 2, run of 3. I can even go backwards, go back 3, down 2, and you can make your nice graph. But before you get too excited, this is where the change occurs. Normally we would just draw a straight line here and we're done. But in graphing inequalities, we're not done yet. There's one more thing we have to do. So let's go back and let's look at this greater than or equal to sign, or less than equal to sign. And let's say that we basically have 4 versions of this sign. We have a greater than sign. I keep doing that. A less than sign, a greater than sign, a less than or equal to sign, and then a greater than or equal to sign. Those are our 4 different signs. That really looks like gibberish just in a line there. But anyways, it's really, that's what it is. And the key part when we graph this line and when we find the inequalities of it, we are going to look for 2 different things. First, we're going to look to see, is it equal to, like less than or greater than or equal to, or is it just less than or greater than? So if it's in this category up here, if it's just less than or greater than, it is a dotted line. Okay, dotted line. So we would graph it with just a dashed line in here. And what that basically means, it means that all the answers that are right along this line, they're not solutions to this equation. They won't work. They won't actually give you a solution that makes sense. For example, one of our solutions is our y-intercept, which is 1 or 0, 1. And so if I plug that into the equation, 1 for y, 0 for x, well, that's going to make this whole thing 0. So it's going to be 1 is less than or equal to plus 1. Well, that's true in this case because it says it's equal to. That would be true. If this was just less than, well, 1 is not less than 1. It's the same. And so that would not be a solution. But because this one has an equal sign, like these 2 down here do, a less than or greater than or equal to sign, these have a solid line. Solid line. And so get my fancy dancy little line tool here and I will make myself a line that goes straight through, and that's great. Okay, step 1 taken care of. Now we know if it's a solid or it's a dashed line just based on whether or not there's an equal to sign underneath this or not. So just to recap, less than or greater than or equal to sign will mean a solid line. If there's no line under here, that means it's a dashed line there. So maybe that's a good way to look at it. If you've got a line under here, that tells you solid line. If there's no line, better make it a dashed line. So you can use that if you want. Okay, step 2. Now, what we have to do is we have to figure out, is this side our solution set to this equation, or is this side of the line our solution set? And it's only going to be one side or the other. Because these are inequalities, it's not saying there's one answer or even a line of answers. There's a whole area of answers here. There's tons of different values that could make this solution set. So if we take one example, and I always pick the easiest one, it's the best thing to do. If you can, pick 0, 0, this point right here. You notice it's underneath this line. If 0, 0 is correct, if I plug it into this equation over here and it's correct, then this entire side is going to be my solution set. I'm going to have to shade this whole side. If it's not correct, if it's incorrect, then the other side will be true, and I'll have to shade in the other side. So let's just take a look. If I take 0, 0, my point 0, 0, and I'm going to go ahead and mark it with a pen here. So I'm going to choose this point 0, 0. I'm going to take it and plug it into my equation. So my value for y is 0 is less than or equal to 2/3 times 0 plus 1. Well, this whole thing becomes 0, so then I'm left with, is 0 less than or equal to 1? And the answer is yes, it is less than or equal to 1, which means this entire side gets shaded. And let me get a highlighter here so I can cover some more area. But this whole area is shaded underneath this line. Hey, where'd that line go? And you don't have to fill in the whole space or anything. Just make sure I know it's clear. See now? Look what I did. Make sure that I know it's clear that the why is it not erasing? That's awkward. Okay, so that side's my solution set. And you might say, well, just because that point works doesn't mean another point won't work. Well, it will. But if you really are just dying to make sure that it's correct, you could pick another point over here and make sure it works if you wanted to. So we could pick a point like right here, and I'm going to change it back to a pen. And I could pick this point here, negative 1x plus 1y. You could do that. And so in that case, it would be plus 1 for my y, less than or equal to 2/3 minus times a negative x, sorry, negative 1. I'm changing out my x for that, plus 1. Okay, well now you got to deal with fractions. So 1 is less than or equal to 2/3 times negative 1. Well, that's just negative 2/3 plus 1. And if I have negative 2/3 here, and I've got a hole here, and I take those away, I'm only going to have 1/3 of this hole left after I take that away. So, and I'm just going to move this thing down here and go 1 is less than or equal to 1/3. So that's the question. Now, is 1 less than or equal to 1/3? And the answer is no, it's not. 1 is greater than 1/3. So again, this is not a solution over here. So we do not shade it in. You shade in the solution set, and you put a solid line if there is a line underneath the inequality, and it's a dashed line if there's no line under the inequality. All right, let's take out another problem here, another example. In this problem, we have y is greater than negative 1/4 x minus 4. Same thing again. Pretend it's an equal sign first. Find my y-intercept. That equals negative 4. And my slope. And that equals negative 1/4. Go to the graph. Y-intercept, negative 4. Slope, negative 1/4 is my slope. So my rise is going to be down 1 plus 4. Down 1 plus 4. And again, I can just keep repeating that pattern. I could also go backwards. Up 1, back 4. Up 1, back 4. And there's my line. First thing I got to say, well, am I going to make this a solid line or a dashed line? And again, we're going to look at this inequality here to tell us that. Because there is no line underneath it, we make it a dashed line. And so, bring out my fancy dancy line tool. Look at that, that's so cool. And that allows me to make sure I place this line correctly. That allows me to draw my line in dashed. And because it's a dashed line, again, because there's no equal to sign under here. There's no line underneath the inequality. Second thing we have to do, second step we have to do is to check a point on one side of the line and see if it works or not. I always, if I can, unless the line goes through this point, because if the line goes through a point you can't do it, the easiest point to work with is 0, 0. Otherwise it's usually 1, 1. But 0, 0 is usually the easiest point to work with. So I'm going to plug that point in. 0 is greater than. And again, I can simplify my life here by saying any time 0 is multiplied by a number, it's 0. So I can just get rid of that and just write in -4, because that's all it is. So the question is 0 greater than -4? Is it? And the answer is yes, it is greater than -4, because -4 is a negative number, and that's less than 0. So that means, once again, that this whole side is shaded in. And I did my little highlighter last time. You don't need to do that. If you just use your pencil or pen and you draw it in like this, that lets me know that you know that this is the shaded side, this is the unshaded side. So, to wrap it all up again, graphing inequalities is just like graphing a regular line, except there's 2 more steps. First, you have to figure out if it's a dashed or solid line. And second, you have to figure out which side of the line should be shaded. And to do that, you pick a coordinate point. If you can, 0, 0, because that's the easiest point. You plug it into the equation. If it's a correct statement, then the side of the line that has that coordinate point is shaded. If it's an incorrect statement, then the other side of the line is shaded. All right, hope that helps you out. And if you have more questions, just come on in and ask me. Have a good day. See ya.